Okay, so now this is chapter 3-3. This is recording number 3. All right, so I kind of was talking fast there at the end. Let me say this again here. We got two formulas here we're going to be messing with. The most important word here is the word given. So given a value of x, that's your data point. That's little Johnny's score. So given a data point of x, what is the corresponding percentile? Here's the formula for it. Here's an example of how to do it. Okay? Now, the next example, or the next formula, I should say, and I don't like the way he wrote this exactly. He should have been more clear that, here's formula number 1, here's formula number 2. So the next topic here is given a percentile. If you are told what the percentile is, I want you to find the value that corresponds to it. So if you want to know, okay, 70%, the 70th percentile, what is the value that corresponds to the 70th percentile? Okay, so here's the process for doing that. So you arrange the data in order, you substitute into this formula here. Okay, you either round it up or you take the midpoint between two guys. So I'm going to let you read that carefully. Read that carefully in your own book, not off the screen here, obviously. Read it in your book, and then let's take a look at the example. So we've got the same data that we had before from 330. 330 was this traffic violations. We're going to use that same information, and we're going to find the value that corresponds to the 65th percentile. So you see the difference, I hope. You look in your book and go back to example 330. In example 330, you were trying to find what the percentile rank was of 16. That was, that data point of 16. Where was it in order? Where was it at in the in order? Okay. Now what we're trying to do is we're saying, okay, I want to know what is the value that corresponds to this 65th percentile. In other words, if I want to be at 65, where am I going to have to be at? Okay, so here's the original data. Okay, it's already arranged in order from lowest to the highest. We plug it into this formula right here. Okay, we're going to look for C. Think of C as it stands for like coefficient or something. Okay, so C is equal to N times P divided by 100. N is the total number of values. There's 10 of them. P is the percentile that I'm looking for. So what I'm looking for is the 65th percentile. So it's 10 times 65 divided by 100. That's 6.5. So 6.5 is where we're at. This is number 1, this is number 2, this is number 3, this is number 4, then number 5, number 6, number 7, number 8, number 9, number 10. Well, unfortunately, 6.5, there is no position 6.5. There's a position 6, there's a position 7, but there's no 6.5. So the rule is, if it's not a whole number, you round it up to the next whole number. Okay? So we round it up to 7. So then we start at the lowest value, we count over to the 7th value. So here we go. 1, 2, 3, 4, 5, 6, 7. That's 20. Okay, so the value of 20 corresponds to the 65th percentile. Okay, so that's the first example. Now we're going to use the same thing. We're going to use the data from example 330. Okay, and we're going to find the data value corresponding to the 30th percentile. So this sounds like the same exact problem, right? But you'll see here in 1 second why it's a little bit different. So the same idea, arrange the data. You use this formula here to get this C. I'm assuming that stands for like coefficient or something like that. So 10 times 30 divided by 100 is 3. So, okay, so it's the third value. Okay, but what do we do then? If it's a whole number, use the value halfway between the Cth, that's hard to say, the Cth guy and the C plus 1 value, okay? So if C is 3, we go between the third value and the fourth value. We go halfway between the third and the fourth value, okay? So the third value is 15. The fourth value is 16, so we go halfway in between, so we pick 15.5. That corresponds to the 30th percentile. Now you may say to me, well, wait a second, that doesn't seem right. 15.5 isn't even in there. Well, so what? It doesn't matter. Just like before when we had the means, the mean does not have to be one of the data points. Okay, same thing here. 15.5 does not have to correspond. You can't have half of a ticket, right? You can't have half of a traffic violation. This is a mathematical abstraction here. 15.5 is the 30th percentile. Okay, so the next topic is this quartiles and deciles. This is a little bit boring, okay? It's a little bit tedious, a little bit of a drudgery. Just stick with me here, okay? All right, so what we're going to do here is we're going to divide the distribution into 4 equal groups. That's Q1, Q2, Q3. What happened to Q4? Hang on one second. Okay, so a little bit awkward language here. He says divided into 4 equal groups and then denoted by, Q1, that's the first group. Q2 is the second group. Q3, I guess, is the third group. Well, why don't we call this Q4? I don't know why he doesn't call it Q4. That's just the way he did it. Okay, so Q1, that's right here. That's the 25th percentile because 25% is below it. Q2, that's the 50th percentile because here's 25%, here's 25%. So you see what's going on here, right? The Q1, Q2, Q3, those are the actual numbers, okay? And then over here, what would normally a rational person would call Q4, that's just the highest data value, okay? All right, so we can find these quartiles using the formula used for computing percentiles on page 153, okay? So that was this formula all the way up here, right here. Actually, that's a typo. It's the formula that's on page 154. Yeah, page 154, and I just double checked in my book, and the printed version of the book of edition number 10, which is the official one we're using, it is on page 154, so it's right here. So this formula right here, that C, I'm just making up a name here. I'm saying that corresponds to like a coefficient, and then P is the percentile you want. So if you want the if you want the 25th percentile, you put in P is equal to 25. If you want the 50th percentile, you put in P is equal to 50. Okay, so it's the same formula as we did before. So that's that formula right here, procedure table. That's on page 154 of the printed textbook. All right, so now let's bounce back down here. So this is wrong. It's not 153, it's 154. Okay, so that's what it's saying right here. All right, so you could do it that way. That certainly would be legitimate. However, he's saying, hey, here's an easier method for finding the quartiles. Okay, so you understand what quartile means, right? Like a quarter is 25 cents. A quarter is 25 cents. That's 1/4 of a dollar. So that's kind of the same idea here. Each of these are quartiles. They're a quarter of the entire range of data. Okay, so again, you just arrange the data in order, lowest to highest, find the median, that's the value for Q2, and then you say, okay, well, let me split the baby again, let me find the median of the data values that are below Q2, okay? And then find the median of the data values that fall above Q2, that's going to be Q3. Does that make sense? I mean, it's just, you arrange the data, you find the middle guy, and then that's for Q2, and then below this you find the median of this guy, and then above this you find the median of this area. Okay, so I'm going to let you go through that. I think it's pretty straightforward. It's just dividing up the data set. Okay, all right, and then so this divides the data set into 4 groups, so it has some value in that regard all by itself. But another use for this is the quartiles can be used as a rough measure of variability, okay? It's called the interquartile range. So inter means between, right? So the between quartile range is the range of the middle 50% of the data values. Now, so IQR, interquartile range, is the difference between the third and the first quartiles. Now, why is that true? Q3 take away Q1. So take a look up here. Okay, Q3 take away Q1. You take this value right here, subtract this. What do you have left? You have what's in between here. Okay, so let's take a look. All right, find Q1 and Q3. That was, we did that before. Q1 was 15, Q3 is 22. 22 subtract 15 is 7. That gives us what's in between. What's in between 15 and 22? What's that amount, or that's range? So their interquartile range is 7. Okay. All right. So this is the idea is this gives you a rough estimate. It's a little bit easier to calculate, I guess, in some situations as compared to figuring out or calculating the standard deviation or of the variance. It's just a rough measure of the variability. Okay. Okay, so remember before we had the percentiles. That's where we divided the data up in units, or 1%, 1%, 1%, 1%. Quartiles, we divided it up by 25%, 25, 25%, right? That's the cartoon that we had. So look in your book for these cartoons, okay? The 25%, 25%, 25%, and so forth. Okay, now we're going to do it by 10%. So if we do it by 10%, here's 10%, 10%, 10%. These numbers up here, the D1, D2, and so forth, those are numbers that tell me, okay, this is the first 10%, this is the second 10%, this is the third 10%. These are the boundaries here, okay? So D1 corresponds to P10, right? Because if you go back to percentiles on page 149, on page 149, we divided it up. The first 1%, 1%, 1%, that corresponded to P1, P2, P3. So all he's saying is that, hey, listen, no matter how thin you slice the bologna, it's still bologna, right? You can divide these up any way you want, whether it's by 1 percentage points, or I'm sorry, 1% intervals, or whether you divide it into 25% intervals, or whether you divide it into 10% intervals. It's the same data, you just are describing it in a slightly different way. So with that in mind, when we look here at these deciles, I'm not sure how to pronounce that, to be honest with you. I think it's deciles. Okay, so D1 corresponds to P10. D2 corresponds to P20. Or let's see here. Yeah, in other words, P10 is the 10th percentile, P20 is the 20th percentile. Well, that's D1, D2. That's the first decile, the second decile. Makes you crazy, right? Not the most important thing in the book, but it's something that I want you to be familiar with, because you'll see this in other contexts, the other textbooks, okay? All right. Okay, so I'm going to let you read this. This is a summary of the position measures. Like I've said before, it's a very good book in the sense that he's really good at summarizing things, putting them on tables. Okay. All right. So here it is, summary of the position measures. It's worth a nickel or a dime or whatever it takes to make a copy of this page out of your book, or print it out from your electronic book. Okay, so now I want to talk about outliers. It's very important, but I'm out of time, so that'll be my last video. I think we'll be talking about outliers. So here's the end of this recording.